Chapter 2, Data. Data is systematically recorded information, whether numbers or tables, together with its context. Note that data is plural and datum is singular. The context of the data can be described by answering the following questions. It's the 5 W's and the H. The first question is, who was being measured? The next question is, what was being measured? The next is how, there's our H. How were the data collected? Then we have where was the data collected, when was the study or experiment performed, and why was the study or experiment performed. Of these questions, the first two are the most important. However, the more of these questions you can answer, the more you can understand the study or experiment you're collecting data on, and then be able to better infer stuff statistically. Let's talk about who first. Below here we have a data table, and each row corresponds to an individual being measured or who is being measured, and we call those individuals cases. Doesn't always have to be a person, by the way. And the data values recorded about each individual are called observations. So what do we observe about these cases? Now the question is, what are we observing? Well, we are observing variables, things that vary about these people. And here's the formal definition. A variable is any characteristic whose value may change from one individual to another, such as height, hair color, brand of car, or number of siblings. Now we have two different types of variables. The first kind is categorical or qualitative, if the possible response of that variable falls into categories, such as hair color or brand of car. The second type of variable is quantitative or numeric, okay, and that is when we measure stuff. So, such as height or counting number of siblings, then that is quantitative data. So we're quantifying something or putting it in a category. Now we have some details. Note, quantitative variables usually include units, which tell how the variable was measured. For example, if you were told the weight of an animal is 12, you wouldn't know very much until you were informed of the unit, e.g. tons or milligrams. Note, observations of categorical data are usually recorded with words, for example, Honda or the color brown. But they can also be recorded with numbers. Zip codes are an example. Living in 85755 zip code isn't necessarily better than living in 75704 zip code, even though the number is higher. It's just another name. Okay, it's just another label for a different category. Another note, many variables can be used as categorical or quantitative. For example, scores on the Ames test, which is kind of like an ACT, are recorded numerically, or let's say an AP test, but they can also be placed into categories such as meets and exceeds expectations. Finally, some variables are neither, such as your school ID number. It doesn't measure anything, so it isn't quantitative. It can be considered categorical like zip codes, but you're the only person in the category. There's one of you, so instead we just call them identifiers. The next thing, the third one, was how. We want to know how the data was collected. The type of data collection, for example, sample surveys, observational studies, experiments, greatly influences the type of conclusions we can draw. After that, we have where and when. Knowing where and when the data was collected can also make a big difference. The results of a poll about the president's job performance will certainly differ depending on where and when the poll is performed. Lastly, why did they even bother to study something or do an experiment? If a study revealed that Advil is the best pain reliever, but the study was performed by the makers of Advil, you should be suspicious. The purpose of the study was probably to help sell more medication, not to be an objective study of pain relief.